Okay, today we're going to talk about bonding. And so far we started off looking at the periodic table, figuring out protons, neutrons, and electrons. Then we looked at neutrons to take a look at isotopes. And then we took a look at electrons to figure out ions. And with ions, one of the things that we figured out is that an atom wants to have its electron shell, valence electrons, the shell either full or empty. And we've been using 2, 8, 8 as our numbers. So 8 is kind of our happy number. And if we took a look at the periodic table, we said that an element like fluorine was in group 7. It had 7 electrons in its outermost shell, and it wanted to gain 1 electron in order to turn into neon. And neon is a noble gas and it doesn't react. And it becomes an ion because it has 1 more negative electron than it's supposed to, so it has a negative charge. So when we take a look at bonding, there are 3 types of bonding. There's ionic bonding, there's covalent, and there's metallic bonding. The first one we're going to talk about is ionic bonding. And ionic bonding happens when a bond is formed between 2 or more ions, and they transfer their electrons. So when we look at this, we have ionic bonds result when a metal reacts with a non-metal. And if we go to the periodic table, these here are our metals. So we have the alkali metals and the alkaline earth metals, and these are called the poor metals, but normally groups 1, 2, and 3 are considered metals, and they are going to react with a non-metal, groups 5, 6, or 7. So when we have groups 1, 2, or 3 react with 5, 6, and 7, we have ions forms. So the metal loses an electron, and if it loses a negative electron, it becomes a positive ion. And we've kind of went over this, that group 1 loses 1 electron, so it becomes a +1 ion. Group 2 loses 2 negative electrons, so it becomes a +2. And group 3 or 13 loses 3 negative electrons, so it becomes a +3. So if we take a look at an ion, like sodium, sodium is right here. Sodium is going to lose an electron, and it is going to end up with a positive charge. And when that happens, it's going to end up acting like neon, a noble gas. Well, group 1s are the typical ions. We have hydrogen, lithium, sodium, potassium. Group 2, magnesium, calcium, strontium, barium. And in group 3 or 13 is going to be aluminum for the most part. So when we have an ion that has a positive charge and it gives its electron to another atom that ends up with a negative charge, like opposite charges attract. And here, here we have sodium in group 1, chlorine in group 7. When it gives that electron away, chlorine will become negatively charged, sodium will become positively charged. And here's a diagram showing that sodium is going to give that electron away. It's going to have a positive charge, chlorine's going to have a negative charge. And it's that opposite charge that keeps them together. And the unique thing about when we have ionic bondings is sodiums are these little ones that they're positively charged, and they are going to attract to all of the chlorines, and we end up getting a crystalline structure. And if you've ever, probably not, but if you've ever made salt water and let it evaporate, you get salt crystals that form in these nice cubes. And later on when we talk about halite or rock salt, we will I'll bring that up again. Covalent bonding happens when they share. And the prefix co means share. Like if you're co-captains, you share captains' positions. That is co-captains of an athletic team, not of a plane. For some reason, a captain and a co-captain don't share responsibilities. But anytime we use the prefix co, that means share. Valent means those outer electrons. So they're going to share those outer electrons. And how this can happen is going to be between non-metallic elements. So when we have these elements over here on the right side of the periodic table, when they get together with most of the time themselves, it is going to be a covalent bond. And that is by sharing the electron. And it's kind of a way of making them feel like they are full or have 8, even though they may not. So here's an example of an element that is in group 7. There's 2, 4, 6, 7, 2, 4, 6, 7. And when they get close, they are going to share these outer electrons and they overlap. So here is our group 7, and this just happens to be oxygen. So oxygen, when they come together, these electrons can share their time between each other's outer shell. So those electrons can go around. And it's that sharing that is going to help them feel happy. And this is between oxygen, this is O2, and that's what we breathe in, that we need to have O2. Okay. Here's water. When we take a look at water I like to call Mickey Mouse ears. And hydrogen on a periodic table, it's not technically in group 1, it has 1 electron, and it will never give up that electron. Hydrogen is only going to share. So if we take a look at hydrogen, hydrogen's in group 1, so it's going to share 1. And this hydrogen's going to share 1. And oxygen's in group 6, so it has 2, 4, 5, 6 in its outermost shell. So hydrogen is going to share. This hydrogen is going to share. And what makes this unique is that we have oxygen with a whole lot more protons, so the electrons, the negative electrons, are going to be attracted to the oxygen side, and that's going to make the head, or the oxygen side of water, negatively charged, and the ears of the water molecule positively charged, and that's what makes water sticky. If water sticks to itself, it's called cohesion. If water sticks to something else, it's called adhesion. And you did a water unit last year in 7th grade, and that's why I don't do a water unit in 8th grade anymore. And our last type of bonding is called metallic bonding. And metallic bonding is going to take place primarily in those elements that are in the transition metals. Or close to these middle ones. Now that includes aluminum and tin and germanium and antimonium and bismuth. Over here, these are going to be the transition metals that we are going to take a look at. And when we take a look at metallic bonding, that metal, if it's like the scissors, there's so many electrons that when that element or when that atom comes close to each other, it has the ability to feel like it's happy because there's so many electrons. And that gives metals a unique property. It's bendable. Okay, and the unique thing is about metals is when you bend them, as you bend them back and forth, every time you do that, you slowly rip those electrons apart because it's the electrons that hold this metal together. And if we take and do this enough, it'll break. And what happens is when you bend it, you're making those electrons choose which side they go to. And by making them choose, they break across. Now, some metals break easier, like aluminum cracks easier than iron. And you think, when you think of aluminum, you think of an aluminum can. It doesn't crack very easy, but that's just because it's so thin. But if you have like an aluminum rim on your car and you smoke a curb, that aluminum is more likely to break, where a metal or an iron rim or a steel rim is going to bend. And there are just different properties that come up. And when we take a look at this, this is an example of moving those metals across. And when we have an alloy is anytime that we add another type of metal that is going to change the properties. Like gold. Gold, if you have a necklace or a ring, is an alloy. It's not pure gold. And that will change the properties by making those electrons kind of choose who they're going to be friends with, and that a lot of times will make it stronger. So that's bonding, and I'm sorry this got a little long, but I want you to be able to recognize ionic, covalent, and metallic bonding. I'm not going to make you draw it. I'm going to give you an example, and you should be able to choose which of the three it is. Thanks.